All right, number 4, we want to know which of the following sets are closed under addition. If a set is not closed under addition, explain why. So closed under addition means if I take anything in the set and I add it to something else, I should get something that's in the set. So let's look at option A, okay, which consists of the set 0. Okay, so 0 is the only thing in the set. If I take any element, and I can take the same element over and over again, 0 plus 0, I still get 0. So I took two things that were in the set, added them together, and got something that was still in the set. This one would be closed under addition. And then we're going to do the same example for each of the other ones. So A is closed because if I take anything in the set, add it, I still get something that's in the set. All right, now we're going to look at B. B says T equals 3 is the set of 3x such that x is a whole number. So we're thinking numbers. So when they say W for a whole number, that means the numbers 0, 1, 2, 3, 4, 5, 6, so on. So we're going to be using those numbers to come up with our set. So the set T is actually going to be these numbers times 3. So if I multiply each of these numbers times 3, I would get 0, 3, and then 6, 9, and we just count by 3s, 12, so forth and so on. Just something that's a multiple of 3. Okay, so is this set closed under addition? So if I take any two elements, will I get something else that's in the set? And it has to work for every one, every element. There cannot exist one that doesn't work. If I say 0 plus 3, I get 3, which is in the set. I could add up 3 in itself, 3 plus 3. Just add up to the same element. I get 6, okay, which is in the set. Since all of these numbers are multiples of 3, if I add two multiples of 3, it will still be a multiple of 3. Furthermore, really how they prove it is they say, okay, let me take one element that's in the set, which is 3, it could be any number, plus another element that's in the set, and I add these up, it will give me 6x. Okay. And if I divide this number by 3, so no matter what it is, okay, I'm still going to get something that's in the set, which is that format of 3x. Now, why did I divide by 3? Because we were counting by 3s. That was part of the original criteria. So this one would also be closed under addition. All right, C, we're given natural numbers, 1, 2, 3, 4, 5, etc., counting numbers. So if I take any two whole numbers, I get another whole number, no matter what it is. And these numbers are also in the set. I could take any two whole numbers. So since the addition of two whole numbers always results in another whole number, no matter how big it gets, because the natural numbers are all whole numbers, this set would also be closed under addition. Okay, now D is a specific set. It is the set of numbers 5, 7, and 9. Okay, so if I take any two numbers, let's just take 5. If I add 5 to itself, I get 10. 10 is not in this set. So, and it would work for any number. I could add any two numbers in this set and I would not get something that's in this set. So because if you add any two numbers in here and you get something that's not in the set, it's not closed. So this one is not closed because, and we can say 5 plus 9 is not in there. No, because B is a finite set. That's not true because you saw A was finite. Finite meaning that it has a limited number or a countable number of elements. So being finite doesn't mean that it's closed, but because we get something that's not in the set. Okay, E, we have the set of all x values such that x is a whole number, and it says x has to be greater than 8. Okay, so what we're looking at is the set of whole numbers greater than 8. So starting at 9, 10, 11, so forth and so on. Okay, so again, since these are whole numbers, if I add any two of them, 9, let's just say plus 10, that will give me another whole number, 19. And if I continued this pattern, we would eventually get to 19, and that would be the same for any two whole numbers. So any two whole numbers we add will result in a whole number. So this one is also closed under addition. And then this set 0 and 1. Okay, so this is the last one we're looking at. F is the set 0 and 1. Is this closed under addition? Well, it may appear so at first. So if you add 0 plus 1, you get 1. Okay. If I add 0 plus 0, I get 0. But if we add 1 plus 1, we get 2. 2 is not in that set. So you got to be mindful. You can add an element to itself. And this is not closed because 1 plus 1 is not in that set.